Chapter 7, number 28. A 4 kilogram particle is subject to a total force that varies with position as shown in figure P7, number 13. The particle starts from rest at x equals 0 meters. What is its speed at A, x equals 5 meters, to B, x equals 10 meters, and C, x equals 15 meters?
So this is the graph of the force in newtons versus x in meters, and it increases from 0 to 5 linearly, and then from 5 to 10 it's constant, and from 10 to 15 it decreases linearly. So in this problem we're given the mass of the particle is 4 kilograms, and the force acting on the particle is shown in the figure P7.13, which we've shown before. And we're also given that it starts at 0 meters and its initial velocity is 0. And for part A, we're given that the final velocity or final position is 5 meters. Part B, the final position is 10 meters. In part C, the final position is 15 meters. And in this problem, we're asked to find velocity of the particle at A, 5 meters, B, 10 meters, and C, 15 meters. So in this problem, we're asked to use the equation, the sum of the work is equal to the change in kinetic energy, which is equal to kinetic energy final minus kinetic energy initial. And we can say that's equal to 1/2 mv final squared minus 1/2 mv initial squared, which comes out, since the velocity initial from the given is 0, it comes out to 1/2 mv final squared minus 0. And also, the sum of the work is equal to the area under the curve in figure P7.13. And so the area is equal to 1/2 mv final squared. So since we're trying to find velocity final, we can rearrange this problem. So we get velocity final squared is equal to 2 times area over m. And we just take the square root of that. So velocity final is equal to the square root of 2 times area all over m. So in part A, we use, since the area under the curve is a triangle, we use the equation area is equal to 1/2 base times height. And the base is 5 meters long and it's 3 newtons high. So we come out with the area is equal to 1/2 times 15 newton meters, which comes out to 7.5 joules. And we can just plug in these into the equation we came up with. Velocity final is equal to the square root of 2 times area over m. So we get 2 times 7.5 joules over 4 kilograms is equal to 1.94 meters per second.
What are you doing?
In part B, we do the same thing, and since the graph from 0 to 10 meters is a triangle, which we found before, and then a square, we use 1/2 B1H1 plus B2H2, which is the area for a square. And we come out with 1/2 5 meters times 3 newtons, as in part A, plus 5 meters and 3 newtons, since it's 10 to 5, 10 minus 5, and it's 3 newtons high. So this comes out to 7.5 newton meters plus 15 newton meters, which comes out to 22.5 joules. And we can plug this into the equation we used before. Velocity final is equal to the square root of 2 times area over m. And if we plug this into the equation, we get velocity final is equal to the square root of 2 times 22.5 joules over 4 kilograms, which comes out to be 3.35 meters per second. In part C, the area under the curve is, again, 1/2 B1H1 plus B2H2, and the third from 10 meters to 15 meters is another triangle, so we use 1/2 B3H3. And we can plug that in. The first two become 22.5 joules as in part B, and 1/2 15 meters minus 10 meters times 3 newtons comes out to be 22.5 joules plus 1/2 15 newton meters. And we come up with the equation with the final answer of the area is 30 joules. So we plug this into the equation like we've done the past 2 times, and we plug it in to get velocity final is equal to the square root of 2 times 30 joules over 4 kilograms. And we come out with the answer 3.87 meters per second.